Okay, so we now look at solving equations that include the modulus function, such as this one here. So we can see that both sides of this equation are indeed linear, and these are the type of equations that we solve. So a linear on the left-hand side equals a linear on the right, and we have a modulus on the left, but no mod on the right on this one. So first thing I'm going to do is just subtract the 1 from both sides, just because that's not necessary for it to be there. So I end up with 2 times mod of x minus 3 equals x plus 3. Now I'm going to look at 2 different methods on how to solve this. Now in the examination you wouldn't be asked for a particular method, so you can choose whichever one you prefer. I call it a graphical. It's not actually a graphical, it is still algebraic. But I'm just going to draw a quick sketch of the 2 graphs, and then I'm going to decide the equations of the lines to solve. So this one here is going to be the mod graph, but translated by 3 in the x direction and then stretched by 2 in the y direction. So it's going to have a gradient of 2 and minus 2, fairly steep. There we go. It's going to touch the x-axis at 3, and it's going to touch the y-axis at 6. Just check that it touches the y-axis at 6. Y-axis means x is 0, so plug in x is 0, we get the mod of minus 3. Well, the mod of minus 3 is 3, and then times that by 2, you get 6. So that is that graph there. So that is y equals 2 mod x minus 3. And now to draw this graph here, so it's going to have a gradient of 1, so it's going to be shallower than these 2 lines, and it's going to cross the y-axis at 3. So it's going to look something like that. And that's y equals x plus 3. So we can see we are looking for 2 solutions. One is less than 3, let's call it x1, and 1 is greater than 3, let's call it x2, x and y. Okay. So the idea behind this method is that we extend the definitions of these lines. So this line here, which continues up there, is going to have equation y equals 2 into x minus 3. It's like the mod has been completely ignored, and it extends down here. But because the red and the black only meet when x is greater than 3, this is actually only valid for x is greater than or equal to 3. Okay. So that should enable us to find x2. So 2 into x minus 3 equals x plus 3. So that's going to be 2x minus 6 equals x plus 3. Subtract x from both sides, add 6 to both sides, I get x equals 9. And that is indeed greater than or equal to 3, so it does satisfy my condition. Once you get an answer to any equation, you should always check it works with the original question, just in case it doesn't, for some reason or another. So plugging x is 9 into here, we'll get 9 minus 3 is 6. The mod of 6 is still 6. 2 times 6 is 12. So the left-hand side is 12. The right-hand side, 9 plus 3 is 12. It works. Okay, that confirms to you that it is indeed a solution to the original equation here. Okay, and by extension, the question. We can do the same thing then to this side. So what is the equation of this line? Well, this line here is going to have the same equation, except the mod bracket is going to be negative. So instead of x minus 3, it's actually 3 minus x, or minus x minus 3, if you like. So again, we state what range of x this is valid for. So this is valid for x is less than or equal to 3 this time. Okay, it's downwards. And this should enable us to find x1. So we have 2 into 3 minus x equals x plus 3. So 6 minus 2x equals x plus 3. Subtract 3 from both sides, add 2x to both sides, and I get that x is 3. Sorry, x is 1. And again, we can check that to make sure it works. 1 minus 3 is minus 2. Mod of minus 2 is positive 2. 2 times 2 is 4, so the left-hand side is 4. The right-hand side, plugging x is 1, we get 1 plus 3 is 4. So x is 1 is also a solution to the equation. Okay, that confirms your answers. And you can stop there. The alternative method is to square both sides of the equation. So 2 into mod x minus 3 equals x plus 3. And the idea behind this, to make sure it works, is that if you square it, it doesn't matter if this mod bracket is positive or negative, when you square it, it'll be the same thing. Such as the nature of squaring. So we're taking advantage of that, is essentially what we're doing. So we're going to square both sides of this, and you'll see that the mod bracket has now disappeared. Because it doesn't matter if x minus 3 is positive or negative. It's still the same thing. And that's going to equal x squared plus 6x plus 9. If I square the right-hand side. And now expand this bracket. So I'm going to get 4x squared. That's going to be minus 6x. Times that by 4 is minus 24x. Minus 3 minus 3 is 9, so that's going to be plus 36. And that equals x squared plus 6x plus 9. Now it's just a simple quadratic to solve. So subtract x squared from both sides. Subtract 6x from both sides. Subtract 9 from both sides. And then divide by 3. And then solve that quadratic, either by factorising or quadratic formula or using a calculator, doesn't matter. So this yields a solutions, x is 1 and 9. Again, check those solutions to make sure they work with the original equation. Okay, we've already checked these because these are the same answers we got from the red method above. So plug in x is 1, you get 4 equals 4, plug in x is 9, and you'll get 12 equals 12. So they are indeed both solutions. Okay. You should always check solutions with this method, definitely, because when you square something, you could yield wrong results. Okay, thanks for watching.